All right, guys. Is everybody on the right page? Okay, we're doing day 3 notes today. This is going to be, the worksheet will be after we do the lesson. So, converting from mixed to entire radicals. Okay? So here we are. All right. All right, so we have to do a little background for radicals. Square root of 4, of course, is 2, since 2 times 2 is 4. Okay, remember that the index of the radical tells you how many times you repeat the product. So there's a little missing 2 there, right? To tell you that it's a square root. And I don't know if you guys have been taught this, but if you multiply radicals, then you multiply the things on the inside, and you get here root 2 times 2 like that, which would be equal to root 4, which is just 2. So in fact, what you learn is that if you ever multiply the same thing under a radical, it's just the number on the inside. So root a times root a is just a. All right, so this rule here, you need to highlight this. Okay? You're going to use this in Math 10C. You're going to use it in Math 20-1 and 20-2. A lot of students, they listen to this lesson and then maybe a day goes by, they forget it. This is one of the most commonly forgot skills from 10C. You need to know how to do this. It's called converting radicals. Converting radicals is super important, okay? It's just a way that we can simplify our algebra, okay? So rewrite square root 24 as a product of 2 radicals. Which one is a perfect square? So, what are all the factors of 24? How could we break down 24? 24 times 1, what else? 12 times 2, what else? 8 times 3, what else?
Please excuse this interruption.
6 times 4.
Please come to the office for a message. Tyree Papin, please come to the office.
Is that it? Yeah, those are all the factors of 24. Which one is a perfect square? Which one? Which one? Which one's a perfect square? Ding, 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 ding. 4 is the only perfect square. Do you guys remember the perfect squares? What are they? 1, 4, 9, 16, 25, 36, and so on. Remember the perfect squares? Okay. Which one's a perfect square? 4. So when we go to simplify the square root of 24, we will choose these 2 factors because one of them is a perfect square. We're doing square roots. We want a perfect square factor. Okay. What ends up happening is the square root of 24 becomes this. Square root 4 times 6. Do you guys agree that 4 times 6 is 24? All right. Well, then what we do is we use the rule above in blue there where it splits the radicals. Okay, look at my screen. Do you see how you have a product on the inside? A timesing, multiplication? We can split the radical sign here and here using A and B. Okay? So what are we going to do with this 4 and 6? We're going to split them like that. And then we simplify the perfect one and leave the non-perfect one. Does that make sense? All right, now I'll show you on the calculator what this looks like. Okay, so stop that. And okay, so on the calculator, type in square root 24. You get this. Is that rational or irrational? Why is it irrational? Decimal goes on random forever, no pattern. It's non-terminating and non-repeating. Good. Now, what was the other thing we simplified? It was 2 times the square root of 6. Do you see how it's equivalent? So it's the exact same value. It's just written differently. All right, back to the lesson. Okay, so some terminology. A mixed radical looks like this. Where the coefficient is not 1. And you have above, it says 2 square root 6 is called mixed. And then the entire is where the coefficient is 1. Whoops. I'll put an A in front there. And then do you have to write the 1? No. So basically what ends up happening is you just write it like this. Because you don't have to write the 1. The coefficient in front is 1, so you don't have to write it. So here are some examples. 5 root 7. This is how you would say this. 5, and to be sure, square root 7. That's how you'd say that. 5 square root 7. What it means is 5 multiply square root 7. Okay? The next one is 1/2 root 10. The next one's 4.2 times root 18. The next one would be 2 times the cube root of 5. These are all examples of mixed. Okay? There's always a times beside these. You know how in algebra you write something like this? AB? What does that mean? A times B. So all these examples, there's this imaginary little times symbol. So this is just times, okay? Does that make sense? It's just times, okay. Moving along. Okay, we did this, what is this? Ordering irrational numbers? What's wrong with these notes? Oh my gosh. We're going to do 2 lessons in one day today. Okay, this ordering irrational numbers, you're going to do it with a calculator. It was on quiz 1. Do you remember you figured out the decimals and then you put them on the number line? I think there was only one person that had problems with that. So, and I'll address that with her later. Okay, so all you have to do, as long as you know how to, and just do it with the calculator, you won't have to do it without the calculator. So as long as you know how to type these into your calculator, you're going to be fine. If you don't, let me know. And then all you got to do is put it on a number line, okay? So it's like, where does this one go? Where does this one go? Where does this one go? Okay? So go back a page. I think we were supposed to do something with these. So my bad. We actually have to work with these. Because we're converting mixed to entire. So right now, all these are mixed. What we want to do is make them entire. Okay? So I'll blow this up. Let's do one at a time. All right. So 5 square root 7. We want to make it so it's just got a coefficient of 1. Okay, so what we do is we take this 5, and guess what we do with it? We square it. Why do we square it? Because the radical on the 7, what index is on the radical on the 7? A tiny little 2 that you can't see, right? There's this little 2 right there that's not there, but it is there, okay? Square root 7 stays the same. So did I change anything by writing it like that? What happens when you square and square root something? Stays the same. So this is still 5. I squared and square rooted. Okay. Now what do? Simplify 5 squared. What is 5 squared? 25. Sorry, my screen's a little bit messed up. I just got to fix it. All right, 25. And the square root 7 I still haven't done anything with. Now do you remember what we do when it was the rule above? What happens when they're split? Put them together. Smush them together. What's 25 times 7? 175. Okay. So 5 root 7 is the example mixed. Square root 175 is the example entire. Does that feel okay? Or are you kind of confused? Okay, on the back of your worksheet, there's some white space. Let's do a couple more. Okay, I want to just do a bunch. All right, so okay, let's start off easy, okay? Can you guys just write these down as I bring them up? 2 square root 6. What's the title of this? Mixed to entire. Okay? So what will we do with 2 root 6? What does 2 become when you square it? 4. So you could just go like this. Is 2 the same thing as square root 4? Mm-hmm. Now what do I do with the 4 and 6? Smush them. I'm skipping 2 steps. I'm skipping a step in here, and I'm skipping a step in here. But if you know your times tables, this should all make sense. If you don't know your times tables, then maybe you need to bring a little chart with you to class. Okay, let's try another one. This one, I won't skip steps. So 3 I would change to 3 squared and then square root it. Then I can type in 3 squared into my calculator, get 9. Then I can merge 9 times 7. And then I can type 9 times 7 in my calculator and get 63. So if you're a person that doesn't know times tables, you should do it like that. If you're a person that knows times tables, the first one's probably good enough for you. So Like this is how I would do this if I was working on a problem that involved this. I would say, okay, well 12, if I need it to be entire for some reason, usually you don't, you'd rather have it mixed, but whatever. 12 squared is 144, and then 144 times 2 is 288. So this is just the square root of 288. See, I just did that in my head? So, truthfully, if you know your times tables, this is not hard at all. Okay? So 12 is the same thing as square root 144. And then I can smush them together for 288. Should we just keep going? Okay, let's just keep going. 5 square root 15. 5's easy. You guys know 5. What does 5 go to? 25. Make it a square root. 25 times 15 is something I can put in my calculator. Sorry, what? Thank you. This is a funny one. 3 is the same as, not 9, not 6. It's 9, but it's not. 3 is not 9. 3 is square root 9. And 9 times 25 is 225. But let's be smart about this one. What is square root 25 up at the top? Isn't that just 5? So really this is just 3 times 5, which is 15. And that's the square root of 225 as well. So it's all connected, okay? It's not going to give you mysteries. Now I'll give you the challenge question of the day. A negative, are you kidding me, Mr. Lionweber? Are you trying to enact your alter ego? Try to bring Tad into the equation here? A negative? Oh my goodness. So this is where we have to be careful. Can you take the square roots of negatives? Look on the back of your quiz 1 I handed out. Remember we talked about that yesterday? Look on the back of quiz 1. Remember we talked about that? You can take the square root of what type of roots? Even indexes only. You cannot take the square root of even indexes. You can take the cube root, though, of odd indices. You can take the cube roots of negatives, the fifth root of negatives. But for even roots, and in this class, for you guys, it will be square roots, you cannot take the negatives. So you got to leave that negative on the outside. Like that. 8 by itself is the same as square root 64. Do you agree? This negative on the outside, imagine it is like negative 1. Okay? So we could write this like negative 1, positive 8, square root 3, like that. We could write it like that. Okay? And that's basically what I did to create this. 8 is the same thing as square root 64. Now I can smush the two radicals together. 64 by 3 is 192. Thanks. Whoa! Craziness. All right. How about we do one more, and I'll let you guys try it. Some white space there. All right, this is an easy one. All right, give it a go. Then when you got your answer, put your hand up. And whoever gets the answer first gets 10% bonus. Got it? Got it? Got it? You guys all get 10% on your next homework. 10% bonus on your homework. It's nothing. It amounts to nothing. I'm just kidding. Okay. Is it negative square root 80? Yeah. I love all of you. Because 4 becomes what? 16. 16 times 5 is beautiful. Okay, now we're going to do hard ones. And only because they're fractions. It's the exact same thing, but because they're fractions, your brains turn to mush. I don't know why. Because guess what a fraction is? It's just two integers put on top of each other like bunk beds. So if you can do integers, you can do fractions. Okay? Do them one at a time. Okay? What do you do with 1/3? Well, just deal with the bunk beds. Who's on the top bunk? The little brother or the big brother? Little brother's got to go up there? Yeah, because he weighs less, right? You don't want him coming down on you. Like Fatty and Skinny went to bed. Fatty rolled over and Skinny was dead. Okay. Don't be scared of a fraction. Who's on the top bunk? 1. What's 1 squared? 1. Don't be scared. Who's in the bottom bunk? 3. What's 3 squared? 9. Okay. Now how do we smush these together? How do we smush these together? What's 1/9 of 27? This is like 27 times the top bunk divided by the bottom bunk. It's definitely 3. Okay, so if they're fractions, don't be scared. You guys want to try one more? Yeah. One more with fractions? Okay. You're out of room? Okay, make some room. We got 3/2. Scary, right? No. Hey, first of all, is that rational or irrational? Pardon me? Why is it rational? Because it's a fraction. All fractions are rational. 3/2 times the square root of 8. All right. What's the square of 3? What's the square of 2? Do them separately. 9 is on top of 4. Now we can smush them. Don't skip steps. Smush them. First of all, 8 is like 8/1. Do you remember multiplying fractions? Top bunk, bottom bunk. 9 times 8 on top of 4 times 1. 72 divided by 4 on a calculator would be 18. All right. Oh, you did 8 divided by 4 is 2. 2 times 9 is 18? Oh, 9 divided by 4 times decimal by 8. That works. But who knows what 9 divided by 4 is as a decimal and then that decimal times 8? Why don't you just do 8 divided by 4? That's perfect. 2, then times by 9. You guys get scared of fractions when it's just integers on bunk beds. How many have bunk bed when you're a kid? Good times, right? How many were on the top bunk? You'd look down and you'd be like, hey, what's up, man? You throw stuff at them? No? Okay, it's already 20 after 11. Okay, work on your worksheet. I'll come around and help you guys individually.